Hey, boys and girls. Hello out there in chat. Willie Ignorant, Carol. Who else? There's like 9 people out there. Command Cyborg, Gurmania. Oh my God.
I think Commander Cyborg was there, and Guerrero did kind of make a hateful statement, but
yeah. What did he say?
At least he's feeding the algorithm.
Initiate preemptive.
Today's live stream is done in the spirit of something that's going on today. This is the super sedimentary bowl of science.
Yep.
So
alliteration.
Yay.
Yeah. In the back room, we figure out what's going on. They take a ball and they get a big bowl and they roll it around in the bowl and they chase it like my cats. That's what the Super Bowl is, right?
There you go.
Yeah, I know what that football stuff is. Anyway. And football is the one with the pill-shaped ball.
Yes, you need to clarify that.
Okay, cool. Because I always confuse that with the little cylindrical thing that they slide around on ice. I don't know what that is. I don't know what that's called, but that's
a little flat circular thing. That's the flat Earth game.
Speed, aren't you from Minnesota?
I am.
Yeah, you can't claim to not know hockey and be from Minnesota. That doesn't work.
I don't know what
it lacks credibility.
In Evelyn, Minnesota, it's the home of the Hockey Hall of Fame and the giant hockey stick. And other than that, Evelyn's a shithole with 3 bars, a bunch of closed businesses, and a whole bunch of meth addicts.
Well, that's what the closed businesses are for. So meth addicts will have a place to congregate.
They have a 50-foot tall hockey stick on Main Street down by where my sister lives.
50 feet, jeez.
Yeah, it's a huge hockey stick. It's quite impressive. Yeah, I have heard of hockey, but yep, I used to skate on the river when I was a kid. We'd go river skating, which was fun. Until the river
was frozen.
Huh?
Was frozen?
Hopefully. It wasn't always frozen. There were some spots that were not, and we had some interesting problems with that.
How do you skate on a river that isn't frozen?
No, our rivers freeze pretty fucking solid. But there's some parts where the water's running rapidly where you'll go through the ice, and we put a foot through the ice once in a while. But you skate long range on a river for like five miles. You know, we used to skate like forever on the rivers. They were just, because they froze so quickly, and the snow blew off. They were just wonderful ice. So.
One year,
kind of relevant. You're talking really about rivers.
Yeah, I think the entire ice skating thing was formed by the flood. Skating in 1 year.
What were you saying, Scott?
Yeah, I was saying that one year, just a few years ago, it got really cold. It got cold enough for a typically, fast enough running river to freeze over. And it was fun to go out and, get some rocks of different sizes and throw them out there and see if they would go through the ice. And in most places they didn't until, things started to thaw out. And then, you would see and, have a competition to see who the first one could be to make the ice crack. And that's about the most fun winter weather ice sport I've ever done, and I've only done it once I was probably 51 then. As a 51-year-old man, was the first time I've ever seen a iced over river.
Yeah.
Rock may beat scissors, but ice apparently beats rock.
Sometimes.
Usually.
Yeah.
Usually.
So anyways, rock, paper, scissors must be a Southern thing.
Or I don't know, to be honest.
So who is Smith when it comes to coal dating? Dating coal deposits and coal seams? Smith. Let's see, what's his name?
Smith dating what?
William Smith.
Oh, William. Oh, yeah, William Strata Smith.
Oh, is that his nickname, Strata?
Yeah,
Yeah,
that was his nickname. Yeah.
yeah, and the faunal succession, meaning the difference in the fossils that they find in the coal seam layers, are very important to finding coal seams and tracing them, and
Basically, the origin of biostratigraphy.
yeah, that might be a place to start. This ridiculous idea that all of that vegetation was the earth was just stuffed with vegetation, and it all got pushed into like little areas by this amazing tsunami flood, and somehow turned into coal within what, a few hundred years, 1,000 years, or
And the oceans too. There were oceans were sludge full of plankton that became limestone overnight, basically.
Yeah. Yeah. Well, that's how Jesus walked on water. It was filled with, right? You just walk out there, and if you walk.
Well, two thoughts on that. One, 100% right, that biostratigraphy is exciting. And two, people have been using coal for literally ever. So, I mean, coal isn't a modern, even a 1000 AD level thing. I mean, you got, quote unquote cavemen burning coal before towns. I mean, it's the coal had to be
I guess
there
you should
before
clarify it as the industrialization of coal, basically.
Yeah, and if it were that old, we'd find DNA in it.
Right.
And we'd find probably red blood cells, right?
Yeah, everywhere, pretty much.
Soft tissue.
You'd probably find a live one somewhere off the coast of Africa or something.
Live coal. Yeah, nice.
Yeah. Yep.
So, as per title of the stream, today I want to discuss some of these geological topics with you, of course, Orge and Speed and Scott here. And hopefully, if things turn out well, this can be a semi-resource for anyone out there interested at all in all the different geodeposits and sedimentary rocks out there, and how this isn't going to be exhaustive by any means, but hopefully we can gish gallop, so to speak, to the point where this amount of evidence against the flood, the global flood, basically becomes highly apparent. All the geology, or basically the last century and a half of geology, pretty much, or even way before that, before the time of Darwin.
Yeah, I agree. It's one of those fun topics where there's so much to talk about that, like, where do you begin, where do you end?
Right? Yeah, exactly. Yeah.
Sedimentary rocks are fascinating and vital to the Industrial Revolution, the way we function in a modern society. And there's so many billions of dollars spent understanding them slightly better, and thousands of people whose their job is to get sedimentary rocks. But no, these 2 or 3 creationists that you see on XYZ YouTube channel, those guys, they really get how it actually works.
I'm not naming any names, but those Austin guys and those Snelling guys out there.
Yeah. Well, I guess I'll kick it off. I caught the end of McKay's debate with, I gotta look it up. I can't remember the other dude's name, but it was McKay. No, it wasn't McKay. It was, what's the other Mick one? The bald guy. McQueen, thank you. Yeah, it was McQueen and someone on SFT's channel like a day or two ago. And someone asked McQueen a question: how do you explain the White Cliffs of Dover, given that they're so high in that unique location? Why wouldn't they be everywhere? And McQueen's answer was weird. He essentially said that tectonics has destroyed some of it. So the White Cliffs of Dover are up there, and then in the middle of Germany, you got chalk beds, and apparently that was the answer. But the guy that McQueen was talking to did a fantastic rebuttal. He said one of the problems with your model is the White Cliffs of Dover have a small subset of mid to late Cretaceous fossils in them and nothing else.
Right.
You don't have Jurassic or Triassic or even early Cretaceous fossils in the White Cliffs of Dover. Now, if they're that tall and existed for that long, why do they only have this small subset of fossils? You got land fossils and fish fossils, but
maybe even just picking the marine ones. Why don't you find any like Eocene fish in there or something like that?
Well, modern fish.
Your modern fish, yeah.
Why isn't there a wrecked boat in the middle of the, like someone's pot or something? I mean, you need to have the White Cliffs of Dover form post flood because it's chalk, right? It would have been destroyed by the flood, so it has to form post flood so fast that you got that gigantic mountainous pure chalk deposit, and it only contains fossils, mind you, but it only contains fossils from the small subsect of. McQueen didn't have an answer, of course, but that is a perfect encapsulation of so many problems sedimentary rocks bring to the creationist model.
And when you say mountainous, you really mean mountainous, because we're talking like 100 meters, hundreds of feet tall, basically, of some of these limestone deposits or chalk deposits even.
Right. So this, what I spotted in this chapter in this book, Principles of Corology, the science of the distribution of organisms. So, are you familiar with corology? I
haven't heard that term.
That's not a phrase I know well.
I had not either, so I'm wondering what the derivation of that is. I've got a book entitled Sediments, Diagenesis, and Sedimentary Rocks, and I have about 5 others too that are. God, but the thing about these books that I would like to point out to the creationists is that for every rock, the size of the grains, the chemical composition of the grains, the modifications, the cementing structure between them, all of this stuff, the shape of the grains, whether the grains have been morphogenically, changed, all of that stuff is a huge physical science with tons of equations where they can calculate this stuff. How in the hell did a flood that lasted 1 year with giant tsunamis that tsunamis are pretty quick. They never quite get slow, right? So there's not a lot of variation in how fast the water's moving. How did it make all these things? How did it make all of these detailed structures in rocks? Every rock.
To add on that, they can also calculate the water depth basically from the sediments. So like not all these sediments were deposited 1,000 feet underwater.
It's just, it's such magical thinking to just gloss over all these details and gloss over these books on these amazing books on sedimentation and the amount of physics that goes into those books.
Right.
Where they can figure out whether there was a boulder on the bottom of a stream and the deposits built up before it, and some of them dropped after it, and then everything got buried and got compressed and created this one type of rock. And that's just a story, but it's a goddamn well documented story that is, that has been tested to a great degree. So anyway,
not even to mention like unconformities, the erosional boundaries between layers. Like, was there like one flood and then it was just a calm period where nothing happened and the rocks eroded away, and then there was another flood, and like, how does that work?
Yeah. So koros means space and place, and logia means a study. So it's a study of space and place. And fucking Wikipedia has an article on it. Wikipedia is like that know-it-all guy You know, that everything you mentioned, he's got something to say about it. You know, God, I hate them. The study of the causal relations between geographical phenomena occurring with a particular region, the study of the spatial distribution of organisms. Now, creationists this is probably something that they're not going to want to talk about a lot. Chorology, right? Anyway,
I want to say something real quick about Wikipedia. Is that there are actually a lot of good people that that work hard to both add content to and to kind of oversee the content to make sure it's accurate. And I know every year I make an effort to give a donation to kind of fund the work, because I think having a really handy centralized starting point for knowledge is a really good thing. So that's my commercial out there for Wikipedia.
I do a monthly donation that I pledge to them, and everybody should, because they need money and they are the greatest resource.
That's right.
Yeah. So
it's like the Library of Alexandria to the world.
It is. It's absolutely amazing. And if they shut down, oh my God, it would be a horrible thing.
Or if somehow the Republicans or the fascist movements of the world somehow take it over or regulate it, it's going to be a bad thing. So keep Wikipedia free. Donate to Wikipedia. I know that sounds kind of contradictory, but
yeah, I would like to shut up a little bit, even though I have trouble doing that, and let and Andrew and Orge kind of say something. Okay, I'm going to shut up. I promise.
So Orge, I'm guessing probably not, but did you happen to IRC the last stream on here the other day, or maybe basically I had an interaction with Kent Hovind, and I was on with Grayson Based Fury, and we were discussing flood geology and all that. And well, we'll actually go into this in a bit, but I brought up aeolian deposits and or sand dune deposits, basically. And apparently Kent thought it was a straw man of his position to say the entire world was flooded water all at once. Like he said, or the way I interpreted it was basically that was a giant waterbed with water on top of it, and it was just slosh around. And so some areas were exposed at one time, and some deposition occurred there, and then other times it was covered by waterborne sediments again. And but it was really amusing, and I do hope you go watch it just to see what you think of how I did, but or how Grayson did. But he was kind of at the end dodging, I think, a little bit, because of course he brought it back to, well, ultimately you think this is a problem from the flood because you think you came from rocks that came from a dot of nothing, or something, whatever he said.
Right.
He of course brought it back to the
weren't you the one he changed the subject on, essentially, and said, let me ask you this, it's not really on topic or anything, but, and then he goes on to the dot thing.
Right, yeah.
Yeah, it's like, man, this is like blatant.
One topic at a time. Hovind couldn't keep it on topic.
I think your response dictated what you said. I don't know if I actually caught it or not. Was very accurate. You know, the aeolian deposits are defined by wind driven. That's like the origin of the word. So wind driven requires, and we have wind driven around us, right? Dunes are, everyone's seen a picture dune. A lot of people have probably been before.
You may not understand how they work, but you've probably seen a sand dune.
Exactly, right? And they leave very distinctive geologic traces. So in order, I was literally picturing it in my head as you were saying Kent Hovind's response.
Right.
And you have like, what? The tide, the ocean tide is so big that it dries up tiny sections of the flood to
Yeah, he seems
what
to think
exactly?
like this whole thing was driven by tide variation and or something. I'm having trouble picturing it, to be honest.
Yeah, yeah. I mean, I think he at least should have said, "Well, these things are post flood," because at least he could
Right.
try to make an argument then. But
Yeah,
he
I
didn't.
think
He tried
the
to say
problem
mid
with that
flood.
though is that he would have to argue that like some of these alien deposits that we'll show in a minute, because I have a few slides on this actually, are like Jurassic or even older. So he would have to argue that those layers, assuming he buys into stratigraphy, of course, then those layers must all be post flood. I don't know if that's something his fans could swallow.
Well, yeah, that's exactly. That's a fantastic point there. Where is your flood boundary? And you can, I
Right.
know Hovind hates the geologic column, but at a certain
Right.
level, it's just stratigraphy. So you can't you can it's mapping at a certain level. It's just mapping.
Yeah.
So you can't have it both ways. You can't claim something is a post flood and then find it pre flood and not have a problem there.
Right. And this could be a whole point in itself that different flood geologists call the boundary at different stratigraphic levels. So you could almost say the whole Phanerozoic eon at this point, because of this disagreement, is post flood.
Right.
Yeah, the other silly thing, the last thing I'll bring that he said was apparently he didn't understand how sand dunes could even be preserved in rock, like how sand could become desert sandstone over millions of years.
I
Like as
believe he doesn't know because he's never tried to figure it out.
right,
Okay,
right.
what we need to do is
water?
show him one of those cartoons of Superman taking coal, squeezing it, and turning it into a diamond, and then he'll understand. All you have to do is squeeze all that sediment, all that sand, real hard, and it'll become sedimentary rock.
But didn't he become very confused? And he says, "Well, you have to have water to form."
Yeah, he thought all cementation has to be by water, apparently.
Yeah, because he has to believe that.
Yeah. I think that's why he was so taken aback when I brought up that example. And that I don't want to give too many points to myself because, of course, Kent is a very slippery interlocutor. But I think I did pretty well in terms of showing how much he doesn't understand geology. But that's just my opinion.
Well, yeah, you can claim that definitely because he ran to his "you're related to an orange" talking point because he couldn't keep up with you. Yeah, exactly.
Yeah. So unless you had something else to say, Orge, I think I'm gonna, if you can share my screen speed. I have a few slides of just like taking some images off the internet. Like you can find this stuff pretty readily online, of these different types of geologic deposits from different depositional or ultimately from different depositional environments, and hopefully with your comments too, Orge, we can go over how we can identify some of this stuff and how we know for a fact that a global flood didn't happen with all these different rock flow. Hopefully I can. Can I present? Does that make it a little bigger? Hold on.
It's pretty big. It's full screen, so should be good. Let me take a look and see what it looks like.
My name is so slow.
It's so slow.
Okay. Can you see it now?
Mode?
Oh yeah, I can see it.
Yeah,
okay.
Yeah, it's good. It's full screen.
So yeah, we were just. Oh, it's full screen. Okay. Yeah, so we were just talking about this alien deposits, and as Orge said, it's wind-blown deposits. I think it's based on the name of some god. I don't know its specific name, but that's where the name comes from. For anyone, yeah, this is the image I brought up to Kent from the Napo sandstone, and of course the probably more famous Coconino, and pretty much anyone who looks at this can see the cross bedding. The bedding planes basically at an angle, and from that you can actually the direction the wind was blowing at that time. So that's kind of cool. Basically, these form from, you can imagine, this is you can see my mouse, right?
Yeah.
These are, I got something wrong. Basically, you have sand dunes, and these are formed from the sand blowing up one side of the dune, and it gets to a point where the wind isn't as strong, gets deposited there. But at a certain point, gravity brings the sand grains down again, and from that you get this sloped deposition, and that's how this cross bedding forms. And it's typically, I mentioned this the other day, typically the cross bedding angle is much or slightly greater than the cross bending angle of a field or river deposited sediment, for example. So that's how you can tell that, or one way you can tell that these are deposited by wind in a sand dune environment and not by a river flowing by, for example. So I hope that makes sense.
I think the biggest, something I would add to your explanation is this is what modern sand dunes look like.
Right.
Like, this isn't some scientist concocting some random idea. This is what a sand dune is actively doing. The difference is the deposition takes a lot of time.
Right.
So, but yeah, it's what you said is more or less accurate. I don't know if these are actually cross beds, because cross beds interlock. So you could probably just say aeolian deposit and not have to use the term cross bed.
Okay.
But I might be off on that one though. But yeah, you're right, because cross bedding is usually a fluvian or water-based thing that we see a lot, where the flow changes and you can watch the change of the flow in the deposit, because there's those lines that you're pointing out are crossing one another. This is showing dominant wind pattern, and as you said, the height of the slopes and stuff like that. Yeah, this is not something we see water do, so there's no reason for us to assume water did it.
Right. And kind of with what Kent was saying about, how is sand compressed into, basically, think of this as kind of the bottom part of the sand dune, basically, that this was a hundreds of meters or hundreds of feet tall, these giant sand dunes in this vast sand desert sea, and this is basically the bottom portion of the dune that's been compressed into rock from the overlying layers over time. And what else was I going to say?
It's aeolian deposits are formed the same way every other sedimentary rock is formed: time and compression and slight heat. I mean, it's the same way core happens,
Right. And I'll point out that these are by no means the only alien deposits out there. Like, there are several others out there. So it's not like this is an isolated event you could point to and say, oh, well, the flood just happened to do that right there or over there. Like, these are in different stratigraphic layers.
Yep. And
they show dunes migrating across the desert. So how does that happen during a flood? So,
well, there's actually, if you look at the grander mapping of aeolian deposits, you can see where they pinch off, where the sand dunes started and where they moved, and then where they stopped moving. Like, you can watch the sand dunes grow as you trace the aeolian deposit over time, which is, again, just it's so fascinating, But professionals have went out there and took these measurements and hundreds of papers on it. Type in Navajo sandstone in a Google Scholar, and you can go back probably to the 20s and 30s. People, pulling out the button compass and taking strikes and dips.
Right. Yeah. I remember what I was going to say. As you were mentioning, like, this is, we base this off of modern measurements of modern sand dunes. Like, we can take a part of a sand dune and cut it in half, so to speak, and look at the bedding layer. And this is, well, not exactly what you see. It's obviously rock, but this is similar to what you see. So we can, based on actual actualistic principles, the theory of actualism, that these were formed in a similar way in a sand dune deposit or a sand dune environment.
Yep. Exactly. And we have no reason not to think that because we haven't seen something non-sand dune create these sort of deposits.
Right, yeah.
You have to make shit up in order to find another explanation.
Right. Like I remember some creation geologists, quote unquote, saying, well, some of them are geologists, but some of them proposing that these, of course, were deposited underwater, and the sediments were carried along as underwater sand dunes, basically. But when they did the calculations, it can clearly be seen that the water depth was barely a few meters, and in fact, water depth. Water velocity was barely a few miles per hour in order to get these cross-bedding features underwater. And how the heck are you going to get all this sand from one location on the continent to another and have it deposited at a rate of only a few miles per hour, or speed, basically? Like, this isn't a very feasible mechanism.
Exactly. And couple that with the idea that the entire world is doing the exact same thing,
right?
But these sort of deposits are few and far between,
right?
So, if the creation, that was when I was talking to Cat Hovind last time, he brought up polystrate trees.
Yes.
Which I can never remember the actual word. Polystrate's not like an actual technical term.
No, yeah.
But I can never remember what they're actually called.
I think they're just called upright fossils.
Something, right?
Yeah.
And he brought this up as, an argument for creationism. And I said, well, why are they so rare? And he's, he got kind of all, your grandma's an orange and stuff. But
Right.
his counter to why are they rare was that when the flood happened, all the logs that had been floating on top would like log jam.
Right.
And then when they log jammed, the polystrate fossil locations are where the trees happen to log jam.
Right. Yeah. And there are a few problems with that, though, because for
more than a few.
Yeah. Guts Gibbon points out in one of our videos, actually, a lot of these polystrate trees have intact in situ root systems, basically, or evidence of regenerative growth, like they were still growing. And to add on to the local environment part of it, like, it's kind of funny, or a bit of a coincidence, how why do we find them in environments or in deposits that seem to be based around river floodplain channels, like places where we know sediments can be deposited fairly rapidly. That's kind of I guess they would say, oh, well, you're just assuming that those are local floods. But again, why are they few and far between? Why aren't they all over the place then?
Right. I mean, at the end of the day, the thing that frustrates me most about dealing with creation scientists, I'm throwing figure quotes at home right now, is they never have the drive, and they don't have the motivation to answer the question, to dig into their own answers.
Right. Yeah.
Right. A creationist is not going to study a unknown deposit. They're all going to go to the Grand Canyon, or the White Cliffs of Dover,
right? Yeah.
Or they're all going to go with tourists. Yeah, they're going to go with tourists so that way they can get a tour group and make some money. Geologists trek through literally everything to figure this stuff out.
That raises a question. Do creationists really have tour guides for the White Cliffs of Dover?
Oh, I'm sure they do. They got them for the Grand Canyon.
Yeah, that's probably
weird.
They probably don't go into much depth as the Grand Canyon, though. Yeah, so the next type of deposit I want to talk about is lacustrine, aka lake deposits. And what we see here are arbs from the Green River Formation, which I think have been discussed quite in detail. But basically, these are annual deposition of these annual layers right here, organic and classic remains of rock fragments and biological material, leaves, stuff like that, in this really calm lake or glacial lake environment. And obviously, for one, that's not exactly a flood environment. This calm lake, suspended material falling out in forms, and also how do these layers form annually interact with other features of measuring time, like Milankovitch cycles, I believe, where you can actually count the layers and say, oh, this was basically a million or 5 million years of time in this one area, basically. Like, how does that happen during a long flood?
Yeah. Part of the exciting part in science, well, that was a bad sentence. One of the exciting parts of science is the interconnectivity of it all. The 15 different ways to reach the same conclusion and then verify your answer is correct, right?
Right.
You know, paleo soils, VOVs, ice cores, radiometric, stratigraphy, paleomagnetic, you know, fossils, all these things all time out together. And the equations don't care about each other, but the answers still equal. So
Right.
that's super cool. But even to a bigger point, how the fuck does a flood do this in such a
Right.
way that it survives, right? I can see a flood depositing slowly, but then when it washes away, that stuff's not solidified.
Right. Yeah, it's basically mud and muck. It's gonna wash back away.
Exactly. You know, what is the fall down rate? I don't know I can't remember the technical term, but you know,
Yeah.
how much of the sedimentation is falling out of the water, and to create these VOVs, that's a question no one's ever answered in the flood world. And then is it fast enough to incur the compaction necessary? And then how is it changing? How are you getting these cycles from the flood, right? Why is this multicolored?
Right. Yeah, especially just hang on to that, how some of these layers have a lot of fine-grained sediments in it. Like, if anyone's looked at dust or clay particles, well, you can't see clay particles in the water with your naked eye, but just in a really long time until they come to a very calm body of water, like the ocean bottom or somewhere like that, and they just drift, you said, fall out of suspension, and get deposited. Like, how does this catastrophic, highly energetic flood event, that doesn't seem very consistent?
You know, and if there is an answer, I'd love to hear it, but rarely is there an answer. Those are things that you could test, but you know, there's no tour guide for that. So no one in creationism is actually trying to answer that question because there's no money in it.
Right.
There's no way to take a tour bus anywhere to deal with that topic.
Basically, yeah.
So we've so the Neal, aka river deposits, we've kind of talked about that a little bit before. You said, they also show a bit of cross bedding, and it's kind of the same thing. A lake deposit, like, how do these little streams or river channels form during a flood event? Like, granted, some river course can flood. That's where we get floodplain. Overflow their banks, basically, but that I don't think anyone's proposing that a river overflowed its banks and that was the Milwaukeean flood,
right? Yeah, that's also same song and dance there.
Yeah.
River deposits are incredibly common throughout the world in all the different directions and locations. So how did the water recede and create these deposits at the same time it created the lake deposits, at the same time it created the aeolian deposits, at the same time it created the chalk deposits. All of these things happen simultaneously from the same mechanism, a bunch of water moving.
Right. And as you were saying, like water doesn't all move in the same direction, or these rivers don't all move in the same direction. Like we can tell from the cross splitting, the water is flowing a certain way, but not in a different deposit. Like it should, well, the water was like it was random all over the place. It was, like you said, sloshing everywhere, but that so like you said, someone would have to do an experiment and say, okay, we can get these cross beds and river type of deposits from a big flood type of event, sloshing water around everywhere.
Yeah, it's the flat Earth problem. Where's your model?
Right. Yeah.
How are you actually doing this? Where is your math? Let me look at something tangible so I can respond in accordance. I can't respond to your Kent Hovind's ad hoc, title, blah, blah, blah. You can't respond to that because he's making shit up. There's no number to run.
I guess in this case, it probably would be a good idea to respond to the flume experiments that they often bring up with George Mackay and all them. And like, it's the same thing where, it's basically showing how rivers deposit sediments, essentially. These flume experiments, that river flume experiments, basically. But from that, you can tell the water is moving a certain speed and moving at a certain depth. Basically, the water was a certain amount of a certain depth, basically, and like I'm studying with my words here. Sorry.
You good?
You get the point, though. Like that. Like if you're doing, sure, you can say, oh, water can do this or that, but can you extrapolate it to a massive flood event, for example? Because that's the real issue. Is, okay, you can say a flood occurred, but that isn't necessarily the same as river deposited sediments or those types of processes.
Nope. That's why creationists just say water deposited for everything, and they completely skip over that sedimentary rocks are like their own degree.
Right. Not
like
all water-driven processes are the same.
Yeah, exactly. I mean, it'd be equivalent to saying, I'm a car I'm a car mechanic. Okay, well, jet engines on Boeing airplanes, those are engines too, so you can fix my jet engine.
Right. Not exactly the same thing. Yeah. Which one do I have next? All right. Here's a good one. Glacial till. All these poor sorted sediments, all the pebbles, cobbles, boulders, the sand interwoven with these large boulders here. And this is called glacial till. Like, this is, again, like we said earlier, seen in modern glacial environments. You can see a glacier coming, flowing over an environment. Basically, it picks up the rocks and leaves scratch marks too. How do these types of deposits form during a flood? Like, I guess some creationists I'm aware, or I think they say that the Ice Age came after the flood. Maybe I may be wrong there. Have you heard that before, Orge?
Usually, I hear the Ice Age is after the flood. Yes.
Yeah.
For literally a couple years.
Yeah. Which I guess some creationists also say that, like, Pleistocene type of sediments where we usually find glacial till, because of course that's when the Ice Age is to have occurred. That those must be post flood, right?
Yeah.
Which
glacial till's another huge problem, because how do you? What's your time frame? What's your scale? How do you fit an entire damn Ice Age into a time when people were recording things? Why is China not talking about all this ice? Why are the indigenous people not talking about all this
Right.
ice covering half the Earth. You know,
I mean, especially some of civilizations were like, oh, it's pretty warm over here, and like anything's drying up or getting colder.
Why does the Bible not talk about this sudden snap of cold? You know,
Right. Yeah, and we're not even mentioning the hypothesized snowball Earth event, like which we also have not exactly types of deposits, I think, but glacial erratics and the same striation scratch marks in the rock that show really ice at near the equator at one point. So there wasn't one ice age, basically, is what I'm trying to say. So there were multiple ice ages in the rock record. How do you explain that?
Andrew, do you want to have a go at Top Dog's question?
Hold on. What's his question? How do sediments turn into rocks? Yeah, so basically, yeah, what Jason said, pressure and time. Basically, you have these sediments being deposited, being laid down, basically. They kind of get compacted by overlying layers. More and more sediment accumulates in these sedimentary basins. The grains get closer and closer together, and sometimes that's enough, but usually there's also a bit of groundwater involved, where there's this kind of underwater streams. You can kind of water laden in the rocks themselves that have minerals precipitating out of them and kind of cementing the grains that were previously deposited, cementing them together to form these. So that's typically the process involved: pressure, time, and sometimes a bit of water itself. Hope that makes sense.
So I'll give you a hint here, and Andrew. When I teach these entry-level geology courses, I always use everyone knows analogies, right?
Right.
The two analogies I use to describe the cementation and formation of sedimentary rocks are: you've been to the beach and you've taken a clump of mud, you squeezed it, and it gets drier, right? Pressure will dry things out.
Right.
And the pipes in your house, they get crud on them. How they get crud on them? Because the water has minerals in it.
Yeah,
and the
pipe water. Yeah, that's
latch onto your pipes.
Yeah.
You know, so between those two things, if you combine them together, you get over time, you eventually get a rock, because everyone knows those two real life instances.
Right. Yeah. Yeah. Thanks for providing a good real world example there.
Yeah.
Hope that answers your question, Top Dog. Glacial till. All right. Guess we'll go on to the next deposits. I know me getting a bit repetitive here, but I want to drive the point home that we have this variety of depositional environments in the rock record that can't be explained by glut. And like I said, we're not even being relatively exhaustive here. There's a lot more to it. So we have coquina here, which is basically formed types of beach environments. See the direction the waves were flowing. Waves, how it works is basically the waves come at the beach at an angle, and because the sand deposited on the beach due to streams flowing in is kind of swept. What do you call it? Not to the right, but to horizontally, I guess. What's a good word for it? It's called the longshore current. Basically, it carries the sand along the beach, and at some point it gets deposited. And so sometimes there are low energy beaches and tidal flats and whatnot in these environments. Sometimes there are high energy beaches, or there are hurricanes involved. That's, of course, hurricanes battering the coast. But of course, beach deposits in general, how does that form during a flood? Because like maybe there is a giant water column or tsunami crossing over the continent, but that's not exactly the same thing as this type of beach deposit, right? Or beach environment.
Yeah, I think what I would add to that statement is beach deposits. Your high energy ones are high energy, sure. I guess you could wrangle a flood into high energy beach deposition,
right?
But low energy beach deposition is a huge problem. Coquina, the left picture there, is incredibly brittle. It's barely glued together seashells, essentially.
Right. Yeah.
So, yeah, you need a very soft, very low energy situation to not crush that stuff up and turn it into essentially lime.
Right.
So the flood, how is a flood simultaneously making coquina and also making high energy deposition?
Right.
You can't have both. And if you can have both, I want you to show me how.
Right. Yeah. Like we keep going back to this idea. Oh, the water was doing different things at different places along the surface of the earth, but like how does that work exactly? Like, I don't know. I keep picturing this analogy of, like I said, a bed with a bunch of water on it is just Well, I think Kent even described it that way. Like the plates were buckling and moving up or fluctuating basically all over the surface of the earth, and that somehow causes all these deposits in different places.
Sounds really high energy, just saying.
Right. Yeah, that does. Like at most you would get a high energy coast environment. Like how does coquina, like you said, and
So
I'm glad you're here to add on to that, because I didn't actually know that coquina formed in low beach environments only. So thank you.
Is he saying that the Earth was like sitting on water, like maybe one of those plastic or rubber floaties, that you blow into until you're like dizzy, and then you lay on it and lay it in the water?
I don't think so. I think he's saying like the whole Earth was basically like the continents and the rocks underlying the oceans were all flexible and just undulating everywhere, and that caused dry places in some areas and really under the ocean places in other areas.
So like with these things like heave up in places for like hundreds of feet,
like a day
and then
or something,
come down, and then the dirt would just like go from the high area to the low area, and then it would flatten it. Okay.
Yeah, something like that.
I'm just trying to get see, what we're trying to do is understand somebody's model, even though they don't have one written out. And what's happening is Kent Hovind's is so ad hoc and just spur of the moment that it's just irrational and hard to follow, impossible.
Yep.
All right. So what did I have next? Here's a good one. Madelites, again, shallower, very environments, and we find not only in the Archean or Proterozoic eon deposit or layers, but also sometimes, here modern stromatolites. Sometimes we find stromatolite fossils in Phanerozoic deposits. Not everywhere, of course, but like these require shallow water conditions where the bacteria can grow upward basically, and it's not too deep so that they can harvest the sunlight and precipitate these mineral mounds around. If the water's a certain depth to be shallow enough, how does that happen if the entire world is covered in a mile or of water, even in certain places?
Yeah. Those are all, again, very accurate points. A couple things I'd add to that. One, you keep having to conflict the flood story with a flood story where it's calm enough to have stromatolites, but aggressive enough to make a mountain chain. How do you have
I hope
both?
That's a good we're making here to everyone.
Yeah.
Sorry, continue.
You can't have your cake and eat it too, right?
Right. Yeah.
But beyond all that, stromatolites are key to the a key part of the great oxidation event and a key part of the formation of iron. So
right, yeah, banded iron formations.
Exactly. So how does a flood? Why did iron not exist before the flood?
Right. Yeah.
Like
That's a good question.
it mustn't have, because and God made oxygen, yet oxygen appears in correlation with the stromatolites. So it's
Right.
you're trying to do all these things. You don't have oxygen feeding organisms pre-stromatolite layers.
Especially when they typically say the dinosaurs existed, all these large creatures existed pre-flood. If there were no banded iron formations, then it must have been really anoxic everywhere. How did the dinosaurs and these large animals and plants survive?
Yeah, but I mean, beyond that, just the plain stratigraphy of it. Like, you
Right.
don't see oxygen breathing fossils below the stromatolite layers before the great oxygenation event. And you see the great oxygenation event where you have your stromatolites like the ones in Australia, and then you climb above that and you start slowly producing these fossils. And
Right.
iron is directly tied to this whole conversation. So it's a big flaming pile of poo.
Yeah, it's a double
Now, before, excuse me,
double issue.
before people start visualizing a huge green tank springing in the leak, how long did the great oxygenation event take before it was completed?
Ooh, good question.
That's, you're talking, tens of millions of years, I want to
Yeah.
say.
Yeah.
Okay, so it was like a dinner party that you just couldn't get away from. It was just really long. Okay.
Yeah,
It's
this
looking,
iron rust precipitating out the water for millions of years, basically, like Jorge said.
yeah, you're talking, well, I was even wrong there. We're hitting billion plus years.
Yeah, I think the number is typically like at least 2.5 ago, but yeah, it probably happened for a couple 100 million years. I think is the estimate.
Yeah, you're hitting couple hundred million, close to a billion years for oxygen to go from practically non-existent to essentially usable.
Yeah.
Right. Yeah.
Just wanted to
Detectable, at
put
least.
that into time perspective there.
Yeah. Yeah. This is way before any complex life forms on it, to give everyone context.
And
When,
but that's the important key there, is you don't find stratigraphically, like not even geologic column level, just like what's below and what's above the rocks. You don't find the fossils before the oxygen.
right.
Why the fuck wouldn't you find the fossils before the oxygen?
Right. Right. Yeah. I think this is the last one I have here. Of course, we can talk more about it, but I think this is one you bring up sometimes, Orge, is these igneous rock deposits, or I guess deposits in a loose sense, more like blood basalt eruptions across the landscape that left all these uh, giant cliffs of lava. Basically, how does that happen during a flood?
Yep.
Especially when some of it has to be continental. It's not like pill lava under the water.
Yeah, like in Washington State and whatever's south of Washington State, I can't remember.
Oregon.
It's like 3 miles deep in places.
Yeah, it's
So quite a wide spread.
Yeah, what you're referencing here are a few different things. First of all, the massive amounts of non-pillow basalts, your extrusive continental granitic rock. How are you making that during the flood?
right.
Essentially, so to break that sentence down a bit, if the entire world's covered in flood and the volcanoes are erupting, volcanoes erupt underwater, and what you just said before, pillow basalt, right? Because the rock is cooling so quickly by being in contact with water that it makes quite literally pillow shapes as it extrudes. So you're not getting your intrusive large grains, your gabbros and your rhyolites and all that jazz. You're not getting that if they're extruding in this manner everywhere, because everything is covered in flood water. But so, yeah. So anyways, that's your first problem, and then your second problem is traps. Maybe you're getting to that, maybe you aren't. But we have a few. We call them traps, and they are gigantic, like
Massive,
half
yeah.
the size of Russia, igneous deposits where volcanoes were just blowing the fuck up for hundreds of millions of years. How does that play? Right? How does that play with the flood?
Right. And like you said, not just one of them. Like we have some in Russia, and these obviously didn't occur all at once, because then pretty much all life would be extinct at this point.
Exactly, but there's like 4 or 5 major gigantic traps throughout the world, and you can't do all that at the same time. On top of all the heat problems that the flood has, you want to add half the world's volcanoes erupting simultaneously to that? Really?
Right. All the heat generated to add on to the heat problem already there.
Yeah.
Now with the traps, it's the lava didn't come out of like the big I forget what they're called, the normal looking volcanoes. Didn't they just come out of the ground?
Yeah, it didn't come out like volcanic bones or anything. This was like fissures in the ground, just oozing lava.
Oozed out of fissures. Yeah.
Volcanoes are formed by progressive eruptions and the rock solidifying on the volcano. That's how a composite volcano is formed. That's why they're called composites. But the traps would be something similar to a shield volcano, is what we call them, which are essentially giant pimples of magma. The Hawaiian Islands have shield volcanoes on them and stuff like that. The Aleutians, no, not the Aleutians. The Hawaiian Island, the big island of Hawaii, is a shield volcano because it's this just giant pimple of magma. It just keeps bursting slowly. The volcanoes on other planets like Mars are shield volcanoes by and large, for the exact same reason. The magma just goes someplace, but it doesn't explode like Mount St. Helens because it didn't have the time to build the composite.
It's also not very laden with gases that could cause it to be very explosive, typically. I'm seeing some
on part of the melt.
Yeah. I see some comments, just looking at the past comments here. I apologize if my mic has been acting for anyone audience. But yeah, those are the slides I had on hand, and of course we can talk about more if Orge is willing. But yeah, those are just a few good questions to ask in terms of the geology of the flood.
Right. My only thing, at some point I'm going to have a 20-minute break to put my kid to bed, but that's my only real thing for the next hour and a half or so.
Does anyone from chat have any questions for me and Orge besides Top Dogs earlier? If anyone is curious about anything.
Yeah, here at Answers in Atheism, you don't have to do a super chat to get your questions answered. In fact, each one of our listeners' chats are super.
Yeah, exactly. Oh, thank you, Carol. I appreciate it. Yeah, thanks everyone for being here in this presentation with me, and thanks Orge for being here too. I hope it's been informative, educational for everyone, to add like I said, the mountain of evidence in geology against a global flood.
I mean, I guess to go slightly off subject a little bit.
Sure.
Your presentation style, and this is just me speaking here. I know God of presentations, but
sure.
You do a good job talking the talk of the hard science about it, but it's these sort of informational this style of presentation lends very well to layman speak and analogy and that sort of thing, right? When I said before, I go, how do rocks form question, and I just broke it down into two things everyone does, because that cements, pun intended, the picture process in your head. So when you're going through
I could probably work on that. Yeah.
Try to tamp it down to what audience you're talking about.
Yeah. So I get excited about the subject sometimes.
I ain't stopping that. I ain't saying that's bad at all. But
yeah, I hear you. I could work on that. Thanks for the constructive criticism.
Of course. Geology just doesn't bring them out, does it?
I'm back. Now,
welcome back.
So, this is an article on polystrate formations in Wikipedia, polystrate fossils. Oh, let's see. The term applied to fossil force of upright fossil tree trunks. Let's see. Coal farming. Let's see. Polystrate trees. Such fossils are referred to as either upright fossil trunks, upright fossil trees, or
upright fossils.
TO assemblages. I don't know what that is. Let's see. According to mainstream models of sedimentary environments, they are formed by rare to infrequent brief episodes of rapid sedimentation separated by long periods of either slow deposition, non-deposition, or a combination of both. And they list the papers. And they talk about volcanic, basically like ash flows that will, cause upright fossils. And there's just a number of other reasons for how they form fossil soils. Let's see, underclay, subaerial weathering.
Yeah, basically big swampy environments where not only coal is forming, but sometimes in these the river delta sometimes overflows. These flash floods happen, and sediment accumulates around the tree trunk. It doesn't die, of course, because trees can live for decades even. And that's obviously shown by like I said, the regenerative growth on some of these fossils.
So then there's formation by regeneration, which is interesting, that some of them being partially buried by sediments, the trees were clearly alive when they were buried. The accumulated sediment was insufficient to kill the trees immediately because of their size. As a result, some of them developed a new set of roots from their trunks just below the new ground surface until they either died or were overwhelmed by accumulated sediments. There's another reason. Then we have carboniferous deglacial meltwater pulses, another possibility.
I gotta bump in here real quick, Speed. I gotta help put my kid to bed, so I'm gonna be out for 15-20 minutes. If you guys are still rolling, when I'm done, I'll come back.
Hopefully we won't run out of steam. Let's see.
Yeah.
Here we go. Upright fossils form. Let's see. Sea fossils. Detailed study. There's a ton of papers on it. I mean, you just have to go to the wiki and start reading about it. And creationists kind of rely on everybody not doing that, because as soon as you do that,
there's all this research out there. You just have to go find it.
Yeah, and here we are. Volcanic deposits. The best documented occurrence of unfossilized buried upright trees occurred within the historic and late Holocene volcanic deposit of Mount St. Helens. So Mount St. Helens is an example where you see the formation of upright trees, these polystrate fossils, right?
Yeah, they typically point to Mount St. Helens and go googly-eyed over and say, "Oh, look, sediments deposited rapidly."
Yeah, but the thing is that they're rare. There isn't that much of them. So,
like a volcanic ash being deposited isn't the same thing as mud and sand being deposited rapidly.
Yeah. So. Yeah, here's basically a little bit of the science behind alien deposits and all of the differences and how carefully they measure it. And the amazing thing about all this is they have just tons of illustrations from current phenomena. Like there's one phenomena that forms this cloud deposit over like there's certain rocks. They match what happens to clouds in the atmosphere because of similar thermodynamics and currents moving around. And they have an example of that. But they have there's a lot of physics involved in this, and it's really tremendously well documented. And those guys like Dr. Crackers and people like that, they completely shit on the just massive volumes of research that has been done on all of this stuff, and they've done lab work too, deep sea environments. I mean, it's just a ton. One could spend their entire life just on studying sedimentary rocks.
Oh yeah. There's a whole field called, surprise, surprise, sedimentology.
Oh, our friend Sal Cordova was going on about genetic entropy again today, and how it's definitely just he had a stream called "The Unhappy Darwin's Birthday," Darwin's Unhappy Birthday, or something like that, because Darwin has been disproven because of genetic entropy, and that's been proven. And that's probably worth going over at another point. Their key arguments for genetic entropy are: we're finding more and more mutations every day. We're decreasing in intelligence. And all of those things are bullshit when you start to look at it. There's this one guy who wrote a paper about how our brains are basically, I forget what it is. They mention him all the time, but he has been like debunked 1,000 times since he published those papers. And there's no really good indication that our IQs are decreasing, or that we have more genetic defects today than we did before, other than through what we know of as to be industrial mutations and chemicals in the water. But I mean, it still hasn't increased all that much. The other one is that cancer is getting worse. It's not. It's getting better. Fewer people are getting cancer since about 1980 something, when we put catalytic converters on those fucking hogs that we drive around. Everything's been decreasing. Prostate cancer is on the rise because there's more and more of us old fuckers, and eventually everybody gets prostate cancer. Everyone, if you live long enough. So.
Did he have any arguments besides diseases are getting more common or something like that?
I didn't watch this particular stream. I'm just reviewing what I know of as their past arguments, and then the idea that mutations accumulate, right? Number one, the mutation, it's like trying to shoot at a gazelle up on a mountain as far as hitting a part of the DNA that actually the nucleotide sequence is going to make a strict difference, right? So most of these mutations are neutral. But they come up with this they see all neutral mutations as slightly deleterious. No, they aren't. Some are really purely neutral. They do nothing. They have no effect on the organism at all. And
even if some of them are slightly deleterious, the problem is that even an occasional beneficial one is going to rapidly increase the fitness of the population. So another way to think of it is, sorry, go ahead.
Think about the concept of mutations accumulating. Okay, you have one mutation that sort of makes the protein 1% less capable of doing what it does, and then you have another mutation that makes it even like 10% less capable, right? Right there, you have a deleterious mutation that is subject to natural selection. As soon as it accumulates enough mutations to matter, it will be purified. The purifying selection will cut it out. And that's what they miss. They have this idea of accumulating rust on a Chevy, like Standing for Truth says. And genetics just don't fucking work that way. At some point, a switch is thrown, and we have a purifying selection that organism never becomes a viable organism or never reproduces. And that's what
that's not even accounting for the fact that a lot of deleterious mutations are lost just purely due to drift.
That's the other thing. They act like what SFT used to say, well, there's 100 mutations every generation, and there are 7 billion people, so there are 700 billion mutations going into the genome. No. They don't add up that way. Populations don't work that way. And they rely on people. They rely on the rhetoric, taking people to reaffirm their belief in what they already want to believe in.
Yeah.
Okay, so for people like Sal, I know Dr. Dan has explained mathematically, just on a graph, how genetic entropy isn't a thing. after he gets done kind of drooling at the mouth and stuttering, what does Sal respond to that? Do you remember?
I think he had a meeting.
Oh, okay. Yeah. During those meetings, we'd have more progress in scientific education if there weren't so many meetings.
He had to run off at like 9:30 at night to a meeting right away. Anyway.
Funny how he doesn't pay much credence to, or he doesn't act very friendly to us, but when Dr. Dan comes online, he's like, I respect, you know,
Yeah, the usual.
a little two-faced.
Here's another good book, Sedimentary Structures by Collinson and Montney, 4th edition. I wonder when was this produced?
It's written by a guy named Nigel, so you know it's very scientific.
And the thing I like about geology and sedimentology and these sedimentary rocks in particular is, it is complicated at some level, but even when you understand the basics of it and you understand the different types of environments and processes that can form it, like these are happening today. And when you have that, then it becomes a really powerful way to interpret the geologic past, basically. And I find it really fascinating.
Yeah.
Kind of like stepping into another world, so to speak, in the past.
Yeah. Well, looking at this is a pretty good book here. This really gets into a lot of stuff, and I think I'm trying to find the examples I'm looking for. They get into just detail on the differential equations involved in solving these various, turbulent flow and things like that. I mean, they have detailed this stuff to such a great degree, and it's just filled with physics. And the creationists have not responded sufficiently to any of this yet. They just handwave all that away.
Are actualists. They understand this. They're fundamentally dishonest. They ignore it.
Well, they probably haven't specialized like a sedimentologist would specialize in this particular field and really get into it.
And don't forget the the ability to compartmentalize, where you can talk geology and geologic and scientific terms at the office, but then believe in this alternate reality known as creationism at the church or at a Bible study.
Yeah, our brains have an amazing capacity to hand wave facts away, Did you hear about the Montana bill to only teach facts to students in high school? They can't teach theories.
What?
Yeah. That's a mess. Basically, anybody who is elected to a legislative position can make a law. They don't necessarily have to be qualified to make that law.
Right. Yeah, there were two Congress people in Montana that proposed that bill, and I'm hoping it got shot down. Because
I really hope that's not based on like the misunderstanding you usually see with these terms. Like
it is.
Surely it's not that simple.
Yeah, it is. It's right in the bill. They say that a fact is something that has been proven, and a theory is an idea that has no proof. That's what they say it right in the bill. That was who went over that? So, some recent YouTube channel. I can't remember which one it was.
I don't know. I got it on one of the Young Turk.
Maybe that's where it was. But boy, would it be one
to look at it and say, "Oh, you're just arguing semantics." Well, at the real heart of it really isn't, because fundamentally it's based on evidence, and we have terms for that based on how much evidence there is, how well supported it is.
And once again, this is a situation where the government is trying to limit the information that can come to people.
Yeah.
And they're trying to limit what you can teach. They're wanting to teach things that are wrong, according to the field in which they're in. And that's real sad, and it's very alarming.
It is sad. Yeah. what Brian says here too.
Yeah. Oh yeah. So we're running out of steam.
I guess are you around, Orge? Still putting kids to bed?
I ran out of steam in the 2000 teens.
Yeah. I got to figure
Yes.
out how to eat something tonight to get some nutrition flowing around in my body again. So, or I'm gonna die.
But remember
Right,
now,
good
because of plastics in the water and the soil and everything, the food you eat is probably polluted.
It's Bree who's still ignoring my
Bree.
email. Bree is still ignoring my email.
Free.
Yeah. But Bree doesn't even know that Bree is ignoring my email because Bree ignored my email and missed it. Now it's buried in your history from I think I sent it 4 or 5 days ago or something like that. I don't know. But who the fuck knows? Anyway.
I'm metamorphic. That's I don't know if that's a joke or not. I'm sorry.
Yeah, I'm starting to metamorphosize. My body is, slowly settling and punching down, and
My brain is calcifying.
yeah, there's that too. So there's really good evidence that bones, their first use was to store calcium.
Oh yeah. And fish and stuff.
Right, and in human beings, even before fish, in human beings, that mechanism is so well established that as soon as you quit putting a load on your bones, your body will say, "Oh, we're a little low on calcium. The shells are getting bare," and it'll just start to dissolve your bones. And then if you put a load on them, they'll rebuild later with new bone, and they keep doing that. And I think the reason that old people break a hip is because they're fucking sedentary. They just start sitting on their butts. They don't do anything. But if you keep, a constant nutritional supply of calcium that's sufficient, and you get out of the goddamn chair once in a while and go run around in the woods, you won't break your hip. Because your bones regenerate all of the time. There's osteogenesis going on all the time. It's one of the few places where you still have stem cells active and stuff. Oh yeah, we were supposed to do. I'm getting ready to do something on embryology. The problem is that I want to be really fucking good at it before I actually start talking about the whole thing.
Yeah,
but
you're probably always going to be better at it than I am.
I know, but there was this wonderful video by Barisi who wrote the book. One of the two main textbooks that are used in developmental biology. And he did a video and he said, everything I learned during gastrulation or something is how he starts out. But then he starts talking about the most important thing is the context of a cell, what's around it. And there's a number of different ways that cells send out messages and receive messages from their environment. And there's all kinds of cool things like the sperm cell of the frog when the embryo forms. The sperm cell has a what the hell? Oh my god! What is that? It has a set of microtubules, the centromere, right in the sperm cell, that actually organizes the zygote. So those microtubules end up injecting into the egg and organizing the egg and creating part of the structure of the frog. And not all organisms do that, but sometimes, like in humans, it's just a naked nucleus that gets into the zygote, right? And there's no extracellular matrix or extranuclear matrix going on. And it's just wonderful to look across different organisms at the different patterns of development.
It's Angelo.
I know.
Wonder what his take is on all the stuff we've talked about in regards to geology.
Flood did it. Where's O'Tangelo?
Flood did it.
Angelo, we haven't seen you for so long. I missed you. You guys still entertaining the nonsense of atheism? Yes, we are. Yeah, because we have no good reason to entertain the nonsense of Christianity.
I like how he brought up that, and we haven't once mentioned atheism in this chat.
I'm so happy to see him that I'm going to make him a moderator again.
What?
Oh my God. So what are these new categories? Standard moderator and managing moderator.
Oh, there are new categories.
Ooh.
Yeah. I gave him a standard. So who can I make managing moderator? Oh, Secular Canadian Mom is our managing moderator. She loves to time people out. I wonder if a managing moderator can time out a standard moderator. I bet they can.
I don't know. Something to read about.
Atheism provides naturalism.
There's now a hierarchy of moderators.
Naturalism provides a ton of stuff to change lives for the better. I had a big stream on James's channel. I'm going to premiere it this week on our channel if I get off my butt and do it, about how the understanding of our brain can really change your life and solve problems with neuroses, depression, alcoholism, various kinds of addiction, dieting, grief, just tons of things. And that all comes from atheism, Otangelo. So I have many answers in atheism, many of them. And I'm just fucking getting started. Just watch me. Anyway. That's the prime.
I wonder if I'm a standard moderator or a managing moderator.
I don't
know if that's even changed.
Well, how the fuck do you know?
I don't know.
Well,
Is there not like a question mark or something that you can click on next to the title?
Okay, I'm going to make Carol the Atheist a managing moderator and see what happens.
I thought she didn't want to be a mod.
Oh, she doesn't? Well...
Or I don't know, maybe it was someone else.
On her application, she says she was willing to work weekends and nights. So I think we need to make her managing moderator.
Okay, I got to remove her moderation status first.
Sorry, Carol. This is for science.
Okay, and then I think I can add her. Okay, now I can add her.
We're going to lose a subscriber if you make Otangelo a mod.
Really?
Yeah, Stephanie says she's going to unsubscribe if you make him a mod.
Okay, I'll change it back, Stephanie, just for you.
For Stephanie.
Just for you, I'll do it. Okay, sorry, Otangelo. We do love you, Otangelo, and we love your inane comments and your absolutely ridiculous way of reasoning, and we love to have you on. So, God Talk is growing daily. Yeah, I've seen a couple of videos, and some of them are pretty weird. Like, are you doing like religious stuff now? Let's take a look at Otangelo's channel.
I mean, religion stuff is always better than intelligent design stuff.
Yeah, that's true.
You don't really have to research anything.
Okay, God Talk. Do I have it as Otangelo or Godless Engineer? God Talk. Oh, here we go, God Talk. Snack, what are you burning? Oh, Snack, do not attack Thor.
I would just love to be a fly on the wall when Snack is doing his thing.
Oh my God, he drapes himself on top of Thor or Loki and just starts biting on him. You know, like his legs are wrapped around him, and they're screaming and hissing and they won't fight back. The fuckers, they're just like totally peaceful. Okay, so here's.
Oh, she just unsubscribed. Sorry, Stephanie.
What, Stephanie? Do a sub because I removed him. The old Otangelo's problem.
That topic, yeah.
Anyway, I removed his moderation status, Stephanie. But we like his creationism. We like his creationism idiocy because it gives us a really good laugh. And we don't want to be an echo chamber here. We do want people to push against this, but. Yeah, there is that.
Within reason. Or with reasons. Let's just say that.
Yeah, so he's doing, let's see, the message of salvation through Jesus Christ. The Shroud of Turin is, if the Shroud of Turin is a forgery, show how it was done and grasp your $1 million prize. Designing Jesus based on the image of the Shroud of Turin. My life was most certainly created. atheists versus Christians. God of the Gaps, really? Okay. So some of the new stuff he's doing is yeah, and he passed me up in subs, so people are eating this shit up. Yeah, if you put out religious bullshit, you can build a channel. I choose not to do that. Though I've thought about it. I thought about, becoming a Ken Ham or a Kent Hogan.
Yeah.
You can make money.
Within reason, yeah, that's a bad phrase, sorry.
Yeah.
With good reasons. Come to us with good reasons. Is what I more meant.
Reasonable reasons.
Reasonable
okay.
reasons.
I think we're done. I think I got it. Okay, guys. Stephanie, no, I'm not going to platform him, Stephanie. He's here to be made. He's here because we make fun of his ideas about creationism, and I try to keep it separate. And it's delicate. I mean, all of these fuckers had done something shitty, and if I deplatform all of them, I don't know. It's a tough thing, but we could talk about it. So, yeah, he did a really rotten thing, and I don't think he showed sufficient remorse. He did attempt apologies in a number of really bad ways, and he kept putting his foot in his mouth. And I don't know. What do you guys think? Am I doing the wrong thing with Tangelo?
I don't know.
I'm okay with him popping up in the side chat because people do like to lambast him really hard.
Yeah.
But yeah, getting him on in the whatever we call this in the room is just a useless exercise. He has he does the potted plant routine when you confront him with facts, and then he tries to dominate the discussion because he's only here to preach and really not to learn anything.
Stephanie, if it's a choice between you and Otangelo, I choose you. So you let me know if I have to.
Yeah. I'd much rather have Stephanie Helms here than Otangelo Grasso any day.
That's a fact. The problem is we just don't get any Christians coming around here,
Yeah. And he's about right up there with Kent Hovind and mockability.
Yeah. Yep, he is. Anyway, email me, Stephanie, and we'll discuss it, and I will go with what you believe to be the proper thing to do because, I don't know, kind of a gray area.
I'm old and clueless.
Yeah, we don't know what the fuck we're doing here. Tell us what to do. Okay.
Yep.
Orge is obviously reading War and Peace to his kids to put them to bed. So.
Yeah, I always like to say that I'm going to get a ticket any day now of operating the internet without a license.
Yeah, there you go. Yep.
Well, I do appreciate Orge for joining us, even though he's not here right now, and I appreciate everyone else for joining us, for listening in. Thank you all.
Yep.
Yeah, it was a great geology discussion. I loved every moment of it.
Oh, thanks, guys.
And Bree, please look back in your email and find me. I'm named Mike Brusnak. You can find me. You can do this. And I wanted to have a stream about the Gaia thing and talk about fungus. Anyway, I'm going to end the stream, guys.
Okay.
Goodbye, cruel world.